Welcome to this tutorial on using oracles in Ethereum smart contracts. In this video, we will unravel the concept of oracles, understand their importance in the blockchain ecosystem, and learn how they can be integrated into Ethereum smart contracts to fetch external data. Let's start by understanding the basics. An oracle is an external service that allows smart contracts to interact with real-world data. Since blockchains are isolated environments, they cannot access external data directly. That's where oracles come into play. In this video, we'll also explore different types of oracles, specifically focusing on decentralized oracles, which enhance the reliability and security of the data being fed into smart contracts. To illustrate how oracles work, let's create a simple smart contract that fetches the current price of Ether in USD. We will use Chainlink, a popular decentralized oracle network. Before coding, make sure you have the following tools set up on your machine: Node.js, Truffle, Ganache for local testing, and a code editor of your choice. If you haven't set them up yet, please pause this video and do so now. Let's start by creating a new Truffle project. Open your terminal and run the following command. This initializes a new Truffle project structure. Next, let's install the Chainlink contracts. Use npm to install them by running this command. Now, let's update our development environment. In your project folder, locate the truffleconfig.js file and ensure that you have configured Ganache as your development network. Here's how you can set it up. With our setup in place, let's create the smart contract. Create a new file under the Contracts folder called priceconsumer.sol. Here's the code that sets up the basic structure. In this contract, we're importing Chainlink's Aggregator v3 interface. This interface allows us to access external price feeds. During contract deployment, we set up a price feed from a reliable source. Now, it's time to find the address for the ETH/USD price feed. You can find it in Chainlink's official documentation or on their GitHub page. For our example, we will use a placeholder 0x your price feed address and replace it once we have the real address. Next, let's deploy our smart contract. Create a new migration file in the migrations folder called to_deploy_contracts.js. Here's how you can set it up. Now, let's compile and deploy the contract. Run the following commands in your terminal. To interact with our deployed contract, we'll use Truffle console. Launch it by running this command. Once in the console, let's create an instance of our price consumer contract and call the getLatestPrice function. Here's how you do it. This will fetch the latest ETH price in USD. The result you get will depend on the current price from the Chainlink oracle. Oracles work by taking data from off-chain sources and feeding it into the blockchain in a secure manner. Now that we have successfully integrated an oracle into our smart contract, let's briefly discuss different types of oracles. Oracles can be classified into three major categories: software oracles, hardware oracles, and consensus-based oracles. Software oracles provide data from online sources, like APIs and databases. In our example, Chainlink is a type of software oracle. Hardware oracles, on the other hand, interact with the physical world to gather data. For example, GPS devices can act as a hardware oracle delivering geolocation data. Consensus-based oracles work by taking data from multiple sources and using a consensus mechanism to determine the most accurate value, which greatly reduces the risk of fraudulent data affecting the smart contract. Another concept we need to touch on is security. Using a single oracle can introduce a single point of failure. Thus, it's often advised to use decentralized or multiple oracles to enhance the security and reliability of data feeds. Today, we have successfully learned to implement oracles in our smart contracts by using Chainlink, and we've also discussed the importance of oracles in a decentralized ecosystem. They act as a bridge between the blockchain and the external world, enabling smart contracts to access real-time data. Before we finish, it's important to mention some best practices when working with oracles. Always ensure that the data from oracles is validated and compare results from multiple oracle sources if possible. Additionally, always keep up with developments and updates from oracle providers. Thank you for being a part of this tutorial. If you found this video helpful, don't forget to like, share, and subscribe to my channel for more content on Ethereum and blockchain development. Leave your thoughts and questions in the comments section below. Until next time, happy coding!